Hi all. So in the last few sessions we had covered critical path method, which is a scheduling technique, and today we will go to a new topic, that's program evaluation and review technique, otherwise known as PERT. This is also a scheduling technique which use more kind of a probabilistic ways, I mean techniques to schedule a particular project. So I have already covered it during the offline sessions, so I'll just refresh it to once again for those students who were not present in the class. So in PERT, there are basically three estimates, time estimates. It's called the first one is optimistic time estimates. Second, the optimistic time estimate, then the pessimistic time estimate, and most likely time estimate. The optimistic time estimate means if all the conditions are all favorable, I mean the conditions are favorable, the time taken for activity to complete. Okay, so that's called optimistic time estimate. So coming to the pessimistic time estimate, from the term itself, we will get an idea what is the real meaning of pessimistic time estimate. It generally means that if the conditions are available are not at all favorable for an activity to complete, so then the time then an activity would take to complete is called pessimistic time estimate. The most likely time estimate, the third one, is normally a value that lies between optimistic and the pessimistic time values. This is the this here we consider the average, the normal situations prevailing. So we can consider the most likely time estimate between the value generally lies between the optimistic and pessimistic time estimates. So this is a frequency distribution curve, and you can see the values of optimistic and the pessimistic. You can see only few number of activities complete under this optimistic time, and the most number of activities, the largest number of activities will be taking the most likely time to complete, and we'll have to calculate the expected time or the average time for activities. We have this formula here. The expected time can be calculated by this formula TO plus 4TM plus TP by 6, and this value, okay, this value T is equivalent to the duration that we used for this critical path method. And we first, whenever you get a problem with PERT method, you in the question itself you will be given the values of optimistic, pessimistic, and most likely time, and from those values you will have to calculate the value of expected time. Okay, and you can use this formula to calculate the expected time TE. Okay, and we have, since this PERT method is related to the probabilistic methods, we'll have to consider two values which is related to probability. It's called variance and standard deviation. Variance is defined as the average square difference of all the numbers from mean value. We will have a mean value, and the individual values differ by a particular value. So variance is the average square difference. So we have the formula here, Vt is equal to Tp minus To by 6 the whole square. We already explained about Tp and To, right? And coming to standard deviation, St, it's defined as a square root of variance. You just take the square root of this variance value, then you will get standard deviation. Okay, so variance and standard deviation, I hope now you know the difference and the formula used to calculate these two terms. So this example was already taught in the class. So this is just for those students who were not available in the class during the last session. So I just explained. So here in this question, what the given values are basically the names of activities, their corresponding TO values, TM values, and TP values. And we have been asked to draw a network diagram, and from that we are expected to calculate the duration and variance of each activities. Then the third part is calculate the early and late occurrence times of each event, then determine the expected duration, and finally we have been asked to find the variance and standard deviation of the entire project. Okay, so from this question, okay, we have already learned how to draw a network diagram. So this network diagram has been developed from the given question. Okay, so this is the AOA network and corresponding AON network based on the given data. And first, next step that we will have to complete is to find the expected duration, right? Expected duration. Here we have this expected duration. So I explained about the formula to calculate the expected duration, that is TO plus 4TM plus TP. TO is the optimistic time, TM is the most likely time, and TP is the pessimistic time. All the values are given in the question, right? And the variance can be calculated by this formula. Variance can be calculated by Tp minus To by 6 the whole square. And from based on that formula, these formulas we have developed this table. So the first column we have the activity. All these values are the activity terms are already given in the question, and in addition to that we have given the value for we have named the activities as A, B, C up to F. Okay, so the expected duration is being calculated in the second column. 2 plus 4 into 5 plus 14 by 6 is value, we got the value to be 6. Okay, and the third column is variance. We have the values already, the formula has been explained, so we calculated the variance value and the corresponding standard deviation. The value of standard deviation can be calculated by taking the square root of variance. I hope this is clear to all of you. So for all the activities coming from A to F, we'll have to calculate the value of expected duration and the variance. And finally, from the variance, you have to get the value of standard deviation. In this manner, we can complete the all the columns. Okay, so we'll get to many values of duration, variance, and standard deviation. Okay, so coming to the next step. Okay, so come you just note down, you just look at these values: expected duration 6, 12, 13, 5, 4, and 16. Okay, these are all the expected duration values. From the network diagram that we have already developed, you just consider the value of expected duration. You just compare what we had learned in critical path method and try to bring some concepts of those method to PERT. Okay, therefore in critical path method, I hope you remember that we used an arrow. Okay, I'll just draw down here. We just used an arrow with two nodes, and we used to write the activity name and corresponding duration, right, in the critical path method. So we use the values of expected duration. We've used the values of expected duration as the duration of the activity. Okay, you just consider this value of 6 is the value obtained from the previous table, right? And from that, we have to use the expected duration. We have to we have to transfer these values to each activities, and we now we have written all the durations. This 6, this 13, this 4, all are the values of expected durations. Okay, now what we have to do next is we have to find, just in case of critical path method, I hope you remember, if we have values like this, what we did before was we found the values of EST, EFT, LST, and LFT, right? Okay, so same concept is being used here. First, in the forward pass, we'll have to calculate the values of EST and EFT. For getting, I just explain it. Anyway, all the activities start from 0. This value of 6 is obtained by adding 0 with 6. Okay, value is 6. And similarly, coming to 13, coming to the activity 2, 4. Okay, coming to activity 2, 4, this 6 will be, one second, this 6 will be transferred to here, right? And then this 19 is obtained by adding 6 and 13. Okay, in this manner we will have to complete all the forward pass steps, and once we reach event 5, event 5, we'll have to consider the backward pass technique, and we'll go back to the first event 1. Okay, so in the forward pass we get all the values of EST and EFT, and in the backward pass we'll get the values of LST and LFT, right? So in this manner we will have to complete this network diagram with all the EST, EFT, LST, and LFT. So we got all the values, and from looking at these values, we should be able to identify the critical path. I told you during the class hours that just consider all these EST, EFT, LST, and LFT. We can distinguish the critical path from the other non-critical paths. So in this question, in this network diagram, you can find that coming to this, see here all the values are same, 0, 12, 0, 12, and then coming to here between 2 and 5 we have 30, 12, 28, 12, 28. These are same, which means that critical path is 1, critical path is 1, 3, 5. You just remember this, okay? So 1, 3, 5 is the critical path. Okay, going to the next step. So 1, 3, 5. During the initial sessions, I told you there are two ways to calculate or find the critical path. The first method is to elaborate all the paths and find the total duration. And the path with the highest value of duration is considered to be critical path. In here it is solved in that manner, and here also we got the maximum value of duration as 28 days, and that was for 135, right? So that is the critical path. Okay, so do I suggest you to calculate the critical path or find the critical path using the second method. I mean this method, by considering the EST, FT, LST, LFT values, you can easily find the critical path. Okay, so coming to, after finding the critical path, the expected duration is 28 days. Okay, you just add the duration of the critical path. Here this 1, 3, 5 means 1, 3 and 3. If we split 1, 3, 5, we have two arrows, we have two activities, 1, 3 and 3, 5. The duration of 1, 3 is 12 plus The duration of 3/5 is 16. So just add it and you get 28 days as the project duration. So we got the project duration, and coming to the variance. Variance here, the question is find the variance of the project. Okay, so variance of the project means sum of activities along the critical path. So we have to consider only the variance of the critical path. So the variance of 1, 3. What was the value of variance of 1, 3? It is 9. Okay. And the next one, 3, 5. What's the value of variance of activity 3, 5? It is already calculated. This is 16. So the total variance of the project is 9 plus 16 is equal to 25 days. Okay, so we got the value of variance to be 25 days, and coming to the standard deviation, just take the square root of variance of the project. Okay, not the variance of any other paths. You have to take the variance, you have to take the square root of variance of the project. Variance, the value of variance is 25 days, and taking the square root is will give you the value of standard deviation, which is 5 days. Okay, so this is how the problem goes. Okay, so I hope you understood how it is calculated. So if when you get a question like this, first you have to draw the network, AOA network and AON network, and from that you have to develop this table. Okay, this table is very important. So from the table you can get the value of expected duration, variance, and standard deviation. And then you have to get the values of EST, EFT, LST, and LFT, and based on that you identify the critical path, and from the critical path you find the variance of the project. You just take the sum of the activities lying, sum of the variance of the activities lying on the critical path, and you get the variance of the project. That's mentioned in step 5. Okay, coming to step 6 is the standard deviation. For getting the standard deviation value, you'll have to take the square root of variance of that project. Okay, so I hope you understood the problem. So we'll go to the next topic. Okay, so coming to the next topic, it's another part of PERT method. The questions may come from this topic also, so all of you please listen to what I teach from now onwards. So probability of completion time for a project. So here the questions will be like this. As I told at the initial part of this video, PERT method is related to probability. It's a probabilistic way of scheduling a project. So, in this, sometimes questions may come in such a manner that they will give us, they will give us the probability of completing, and we'll have to calculate the duration of the project. Similar questions may come. So, let's see, I'll explain how we should approach such problems. So, step one, okay, so it's simple, you just listen. So, as I told before, we have this variance and standard deviation. The formula for calculating the variance and standard deviation you have already written, or you have already seen. Okay, so here it's again mentioned the standard deviation sigma and the variance sigma square. So we have already considered the formula for calculating standard deviation and variance. So again, a new formula is mentioned here. You just look into this. So Z is equal to Ts minus Te by sigma. Okay. So what is Ts and Te? So we have the terms explained right here. Ts is a scheduled completion time. T is the earliest time, and Z is a probability factor. So, based on this probability factor, there is a table like this normal distribution function table. Okay, so here there are two columns basically. Actually, this first column, this is second column. Again, this column is repeating. Okay, so basically we have two columns here, and for the first column, it's Z. Z is a value of probability factor, and if we can find this probability factor Z, we will be able to calculate the value of probability from this value. Okay, so our aim should be to calculate the value of Z. Okay, you just understand that for the time being. The value of Z varies from 0 to positive 3, and sometimes it can go up to negative 3 also. And for each value, we have a particular value of probability mentioned in percentage. Okay, and suppose if we are given a value between, suppose if we get the value of Z as 0.35, that exact value is not shown in this normal distribution function. You will have to iterate. I mean, you'll have to you'll have to find it based on the values of zero point 0.3 and 0.4. Okay, so by interpolation, you can calculate the value of 0.35. So it will lie between 61.79 and 65.54. That value of probability will lie between the 61 and 65. Okay, so coming again, so here so in the problem you will be given, you will just understand the terms and you just substitute it. That this is the only thing that you will need to do when questions from this part is being asked. Okay, so coming to the question, here in this question, a small project consists of 7 activities. The time estimates in weeks of the different activities are given below. So in this question, the details of a small project with 7 activities are given, and the values of TO, TM, and TP are given, right? So TO is optimistic time, M is most likely time, TP is the pessimistic time. So you just have the values of TO, TM, and TP for all the activities, and we have been asked to draw a network based on the value, find the critical path, then third part, coming to the third part question, we have been asked to calculate the probability of not completing the project within 18 weeks. We have to calculate what is the probability of this project, of probability that the project will not complete within 18 weeks. Okay, so the fourth part is what is the probability of completing the project 3 weeks earlier than the expected time. We have an expected time, and what will be the probability of completing the project 3 weeks earlier? That's being asked here. So we will see how to calculate the problem. Okay, this is very easy. Just listen. Step 1 is to draw the network. I hope you know how to draw a network. From the beginning of this module, I have told you many times that drawing network is an essential skill that you need to develop in this module. This will be, I mean, the drawing network is the very first step for all the problems. So if you don't know how to calculate, how to develop a network, you won't be able to complete the numericals. So it is very essential that you learn how to draw a network. So based on the given data, we have developed the network like this. Okay, so the coming to the step 2, calculation of expected time. Just like what we did in the previous problem, we have mentioned all the values in table with the 6 columns. Oh, first coming to the first column, you can check here. The first column is activities is given in the question. Is given. Okay, this is given. TO is given. Most likely time is given. and pessimistic time is also given. Okay, so the only two things that we need to calculate here is expected time TE and variance sigma square. Okay, so formula for calculating expected time is TO plus 4 TM plus TP by 6. TO, all this value TO, TM and TP, all the three values are already given in the question. You just substitute the values and get the value 2. Okay, from 7, 1 and 1. Okay, and similarly you calculate the value of variance from this formula. So in that manner you can complete the entire table. Okay, so I'm going to the third step. So network duration and the activity time. Okay, so I'll just show how to explain it. One second. Okay, so this is the network diagram with the corresponding activities for all the activity durations for all the activities. Okay, so we'll have to find the the activity times. I'll just explain. So during the class hours, I told you how to express all the values. You'll have first you have to explain the representation pattern. For example, activity mentioned here, its corresponding duration, and then EST, then EFT, then LST, and LFT. Okay, so these are all the um, terms which we will have to calculate. For that, first we will have to go with the forward pass. For example, we will go with the activity S02, then zero 04, then 03, then 410, then 23, then we have two values 3 and 10 here. So if we in the forward pass we always consider the highest value. Okay, so 10 and 17. Okay, and the coming to the last F, activity F, we have to take 3 and 8. Okay, so 8 is obtained by adding this 3 with the duration 5. Okay, so in that manner we completed all the EST, FT values. After getting all the values, we'll have to go back from the sixth event to the first event. For that, one second. Okay, first we'll have to go to start with 17 and next will be 10. This 10 is obtained by subtracting 7 from, sorry, we have to subtract 7 from 17, then you will get 10. Then here also it will be 17 and 12, right? Then this 10 will be moved forward when backward to 10 and 4. Here it will be 10, 9, then this 4 and 0, then here it will be 9, 7, and lastly 12, 9. Okay, so in this manner we completed the entire network with all the ESTFT, LST and LFT. Okay, so the next step is to find the event time. So while again this event time and activity time can be confusing sometimes, so be very careful while calculating the event times. Okay, so I'll just explain. So we have to depend on the previous this picture, previous activity times to calculate the event times. So I'll just explain the method. So here we have, here you have to mention, for example, t, we have two event times for all the events, that is te and tl. Okay, tl1 and te1. So te1 will be 0 and tl1 will be 0. Okay, so coming to uh, second event. Okay, so we have te2 and tl2. te2 will be, since you can check the activity times, so the second event will start, the earliest time will be 2 and the latest time will be 9. Okay, so you just compare it with the previous picture. Here you can see the 2 and 9, so that will be, here it we can be te 2 is equal to 2 and tl 2 is equal to 9. Okay, okay, that's what is written over there. And coming to the third event is t t e3 is equal to 4 and tl3 is equal to 4. Okay, so next is fourth event. So tl4 is equal to 3 and TL4 is equal to 12. All right. Fifth one. Fifth one, TE5 is equal to 10 and TL5 is equal to 10. There may be some confusion at this point, fifth event, because when we check the activity times, we have there are several values. For example, there are two values of EFT. For example, when we consider this event, okay, so we have this 3 here and we have this 10 here. Which will be the value of TE5? You have to take the highest value. Or for example, if there are any critical paths, you have to consider that value only. So we took value to be 10 and TL5 will be 10 itself, because it's same here. Okay, so just consider that. And the last sixth event will be TL6 is equal to 17 and TE6 is equal to 17. So in that manner you will get the event times. Okay, the solution is mentioned here. So all the event times are obtained. Okay, so step 4 is complete. So next is critical path. From these values, okay, from all these values, we have to identify the critical path. You can just compare the values, EST, EFT, LST, LFT. So here you can see the values are same, right? 0, 4, 0, 4. Then here 4, 10, 4, 10 is same. And then it is 10, 17 and 10, 17. So which means that critical path will be 1, 3, 5, 6. Okay. So we identified the critical path. So that's what is mentioned here, 1, 3, 5, 6. So the variance of critical path. So variance of 1, 3, variance of 1, 3 is equal to 1. Okay, so variance of 3, 5 is equal to 4, and variance of 5, 6 is equal to 4. So you just add it and you get the value as 9. So from where you got the values of variance is already calculated here, right? Variance values is also all here. So you just take the values from here to this portion. So you got the variance as 9, and from that value you can calculate the value of standard deviation as 3. Just take the square root of 9 and you get the value as 3. So the project length will be 17 weeks. From where you got this 17? From this you just take the duration. Okay, duration of 1, 3, 5, 6. This is the critical part. So duration of 1, 3 plus duration of 3, 5 plus 5, 6. So what is the duration of 1, 3? Duration is 1, 3 is 4, 4 plus 3, 5 is 6 plus, and 5, 6, 7. So 3, uh, 4 plus 6 plus 7. Okay, so 4 plus 6 plus 7 is equal to 17. That's what is written here. Okay, so we got the project length. Again, step 7. Okay, so this is the real part of PERT. So the question was like this: probability of not completing the project in 18 weeks. So this is underlined here, not completing. So what we should do is first we calculate the probability of completing in 18 weeks. Okay, so the maximum value of probability will be 100%. Okay, so first we calculate the question. In the question we have been asked to calculate the probability of not completing, but here we are calculating first the probability of completing in 18 weeks, then we subtract it from 100. Okay, so how to calculate the probability of completing the project in 18 weeks? So we, for that we have this formula. It's already, I think you have already noted that P of Z less than or equal to Ts minus Te by sigma. So Ts, what is the value of Ts? Ts is the scheduled. We have been asked, the value given in the question is 18 weeks. Okay, 18 weeks. Ts. So what is Te? Te is the duration we obtained in the previous step 17. Okay, this 17 will be Te. Okay, so this is 17 weeks. Okay, so sigma value is already obtained 3. Okay, in the previous step we already calculated it. So we have all the values and we got the value of Z as 1 by 3. Okay, 1 by 3, which is almost equivalent to 0.33. So you just check the value of Z. Z is less than or equal to. So we consider the value of Z as 0.33. So here 0.3 is given as 61 and 0.4 as 65. So this value of 0.33 needs to be calculated by interpolation and we will get the value as 63 percentage. Okay, so this 63 is the probability of the project for completing it in 18 weeks. But the question is, we have been asked to calculate the probability of not completing the project within 18 weeks. So we just subtract this 63 from 100. So that is what is shown here. 100 minus 63 will be the probability of not completing the project in 18 weeks. That is, then we get the value as 37 percentage. So the next step, the last part of the question is we have been asked to calculate the probability of completing the project 3 weeks earlier than expected. The expected time is 17 weeks, right? The expected time is 17. So we need to check with the 14 weeks, 3 weeks earlier than, so we have been asked to find the probability of completing the project in 14 weeks. So that is what we need to calculate, right? So P of Z less than or equal to, here TS minus TE. TE is 17, it won't change. TS keeps on changing as per the question. So TS, in the first case it was 18, now it is 14. So 14 minus 17 by 3, this is sigma standard deviation value. So we got the value as -1. Okay, so we need to check where is this -1 coming. So see, here it is -1 in this table. So the corresponding value of probability as 15.87. So it's written 15.9 as the value. So for the university question, if this type of problems are asked in the question paper, you will require the standard normal distribution function. Okay, that time you can I'll be there, and I'll inform the um, example representative regarding that. You will be given the table. Okay. So the last question from this topic is, a certain project takes 40 days along the critical path. So a certain project takes 40 days along the critical path and has a variance of 9 days. Compute the expected completion time for the project with the following probabilities. So in this question, we are given the values of probabilities, and we'll have to calculate the schedule time, or in how many days it will be completing in given that probability, with the given value of probability. Okay, so the first part, in the question itself, it's given project takes 40 days along the critical path. If it's along the critical path, it means that the value of TE is equal to 40 days. Okay, the value of T is equal to 40 days, and the variance sigma square is equal to 9 days. Okay, so we have to calculate the value of standard deviation. Sigma is equal to root of 9. It's equal to 3 days will be the value of standard deviation. So the first part, the value of probability is 94.5. So for value of 94.5 percentage, from the table, we got the value as 1.6. Okay, so here you can see, for the probability 94.5, the value of Z is 1.6. Okay, so we got the value of Z as 1.6. We just substitute in this formula. We have to, in the question, we have been asked to calculate the value of TS. Okay, so expected completion time for a particular probability, that is TS. So in order to calculate TS, we already know the value of T for value of TZ, TE, and sigma. You just substitute all the values and you will get the value of TS as 44.8 days. The same pattern is being repeated in part 2 and part 3 of the question. Second part, the probability given is 46%, and the Z value we get as minus zero point 0.1. So we get the corresponding value of TS as 39.7. And the last part, the probability is 75%, and the value of Z we get 0.69 from the table itself. Okay, we are in all the problems we are here depending on the normal distribution function table, and from that only we will get the value of probability. So the value of TS we got 42.07. So these are all the different problems that can come from this topic in the university question paper. Okay, so the what are the difference between CPM and PERT? So PERT is basically, and see, these topics will be asked for the short answer question, and you will have to learn at this topic, PERT and CPM differences. So PERT is basically an event-oriented diagram, and CPM is activity-oriented. PERT are times unrelated to cost. CPM times are related to cost. In PERT, there are three time estimates. That is optimistic, pessimistic, and most likely. But in case of CPM, there is only one time estimate. So in PERT, it's basically an analytic in concept, and coming to the CPM, it's basically synthesizing in concept, and it is more kind of deterministic network. In PERT, it is probabilistic, and CPM, it is deterministic. Okay, and PERT regarding the application, PERT is used for research development project basically, but all the projects, construction jobs, the practical in industry, we mostly prefer CPM as a scheduling technique. So here I'm stopping my video, and you have some more problems in your handout, and uh, you'll have to practice it. Okay, this PERT problem.